Hi everyone, welcome to Learn with Preeti section. In the last section, we have learned how to create a thread using thread class and then runnable interface. Those who have not watched my previous videos, I strongly recommend you to go through those, go to that video. That will be really helpful for the section. So the first one is now in this section, let's understand the runnable interface and its advanced real traps. Okay, first the question number one, runnable plus executor service. First, when we see the executor service, this is a very important interview question. People will ask, what is executor service? Executor service is nothing but it is helpful for us to assign the thread of pools. Thread of pools, we can use that across in our system. Let's consider executor. Here we can see, right, new fixed thread pool of 1 I have included. If you want to include 3, 5, your wish, 10, we can include it. Let's say you are running a for loop, then only one thread will be created. That thread will be used. That the same thread will be used for every input request. That to create a thread pool of threads, we can go for executor service. So let's come to this question. Executor service executors dot new thread pool 1 runnable R. This is a task which we have created. Now service dot submit system dot out of printer of maintain service dot shutdown. Now the output is whether this error will be thrown to the console or not. The output to that is no, because the submit will swallow whatever data we are passing. Okay, we are not basically returning the response back to the caller. If you see service dot submit only I have called, I am not returning anything, so that will be swallowed. It will not be displayed to the console. Output, no, it will not print anything. Output mostly will be like task started and then main done. Okay, this is completely swallowed. Why does this happen? Because you call service dot submitter. Internally, submit wraps your task inside a future task. Any exception thrown is captured and stored in the future. It is not thrown through the thread. It's not printed to the console unless you call future dot submit or future f dot get. This exception will come here. You will never know the task is failed. Okay, this is a production bug because this is very dangerous and risky. No logs will be printed, no alert. System continues as if everything is fine. Payment processing fails silently. Kafka consumer stop, data corruption. So debugging becomes a nightmare because there is no visible error. Okay, so then now the next question comes in executor service. We have two methods available. Okay, one is submit method and another is execute method. What's the difference between both? So service dot execute method is exception is thrown in worker thread. JVM prints it to the console via the uncaught exception handler. Good for debugging. So service dot submit is basically exception is captured inside the future. When we call get method, then only it will be printed. Okay, so submit only when you handle the results. We can use execute. Then the next question comes in, when we can use submit. If we want to store our result to some variable, then we can go for submit. Execute is return type is void, so we can use this execute method when we want to do some fire and forget task. Okay, the next one, even with execute relying on console log is weak, then the best practice is go for thread factory, custom thread factory. So execute method execute will throw to the thread, it's visible. Submit will swallow the result to the some variable. Only if we call, we will get to get method. Next, here you can see I have created only one thread. Now service dot submit throws new runtime exception, boom. So what is the output of this one? Why you may never see this exception internally, as we discussed, submit wraps your task inside the future task. Any exception thrown is captured and stored inside the future. It is not thrown to the thread. It's not at all printed to the console. So exception will come here. What happens? Return the future. What method returns the exception? Only future dot get. Okay. So moving on to the next question. Thread local plus reusable use. I have created the static local one. Okay. Next we have a executor service which has a thread pool of size 1. Next we have this task runnable R. Next I have for int I equal to 0, I less than 3, I plus plus service dot submit of R. As we all know, submit method will follow the result to the swallow the result. It will assign the response to the future task. Submit the response to the future task. Only if we call the get, then only we will get the output. So here if you see, I have included the loop. I'm calling the submit for 3 times. Only one. If you notice here, I have created only one thread for every 3 iterations. Here I am iterating till 3. So for every 3 iterations, no new thread will be created. Only one thread will be used for all 3 things. Okay. Now if you see service dot shutdown, but inside this what I am doing for all with only one thread, 3 iterations, I am multiplying with 100 and I am trying to get local dot get. Okay. So what will be the output? Why is this dangerous in thread pool? Thread local. If you see here, we have included thread local. Thread local is nothing but it will create the stores the data per thread, not per request. You are requesting how many times? 3 times. Okay, 3 times you are requesting, but the thread local stores per thread. How many threads are created in this program? Only one thread created in this program. So what the same thread is used for all 3 tasks. So task 1 uses a thread 1, sets value let's say 42. Task 2 uses the same thread 1 and sees a previous value. Task 3 again same. So thread local value is not cleared automatically. It leaves as long thread becomes dead. Okay. So what bug happens in real system? Let's consider like request A user Alice, thread A sets Alice. Okay, request user next the user Bob signs in. He will then also same thread 1 will be reused. Alice will not be cleared at all. Bob will see Alice data, which is very very crucial and very critical. Okay, so root causes thread pool reuses the threads. Thread local is tied to thread lifecycle, not tied to task or request lifecycle. So how to fix this one? Once we have completed the try block, inside the final you clear the thread local, automatically it will be removed. No leftover data, no memory leak, no cross request contamination. What if I create executor service with 3 threads? Okay, here you can see I created 3 threads. Poll as 3 thread. Okay, T1, T2, T3. You submitted the 3 tasks, like how inside this one we have for loop, we are submitting 3 times. 3 times. Task 1 will set the value as 10. Task 2 will set the value as 25. Task 3, let's say it's 70. Look safe because 3 times the value is being set. Okay. The problem still exists because threads are used, not destroyed. Scenario with more tasks. If I include 6, the service.submit for execution might be like task 1 T1 sets 0, task 2 sets 20, task 3 sets 30, task 4 T1 old value still there unless overwritten. Okay, T2 will still see the old value. Similarly, task 6. So it gets splitted for the entire 6 requesters. Only 3 threads will be created. The same thread will be used for the same 3 threads will be used for all requesters. Okay. Your current code local.set, here you are overwriting every time, so you may notice this issue, but in real time you often get local.get equal to null. Okay, this is what the next one, subtitle bug. Okay. Sorry guys, there was a network issue in my end. I'm proceeding further. So the next one is okay. Moving on to the next question. In our current code, we are setting local.set and then we are trying to get. You are overwriting everything, so you may not notice a issue. But in a real system, local.get equal to null, then you are setting. Now the bug happens. Task 1, thread 1 will be used. Set Alice. Task 4. T1 will be coming because task 1, task 2, task 3 will use 3 threads, right? When it comes to task 4, the local.get will not be null, so it will skip setting the new user. It will still use Alice. So key insight: increasing the thread reduces the probability, not the problem. One thread bug happens, 3 thread bug happens sometimes, another bug happens rarely. Even one wrong request equal to obviously the production issue. So how to fix this one? Always when we go for thread local, we need to remove that thread local, so that stores it will be cleared per thread. Okay, even with multiple threads, thread local is unsafe in thread tools because threads are reused. So stale data can leak across tasks unless explicitly removed. Moving on to the next question, runnable plus shared object mutation. We have a string builder. We all know string builder is string builder is not thread safe. If interviewer asks any question like why string builder is not a thread safe, this example we can say this is the best example. So where we have a runnable task, we are iterating till 1000 and we are appending a thread t1 equal to new thread of or thread t2 equal to new thread of or t1 dot start, t2 dot start. If we have observed, I am passing the same task to the both threads and I am starting the both thread. Okay, let's first understand how string builder works. String builder's actual size is 16. When size gets exceeds, it will multiply internally count equal to 0 by 16. So whenever the capacity exceeds, it's growing using old capacity to 2 plus 2. So 16 into 2 plus 2, 34, 70, 142, like this it will keep on growing. Whenever resize happens, what Java does, it will copy the old array content to the new array content like this. Okay, old array, new array and the count. What is a expected length? What is the actual result? The expected length something we are expecting. Okay, the we might be expecting around 2000 because we have created the two threads. Okay, but what actually happens, we will get a exception saying array index out of bound exception, array copy lost at destination. Why string builder is dangerous? Why we are getting this error instead of a getting appended for 2000 times? In The reason is string builder here it uses byte value. When you do sb dot append of a, internally it checks the capacity. If it is full, it resizes, copy the old data to the new array, append the new data, update the count. Two threads doing append at the same time. Okay, let's see. Thread 1 sees a capacity full, starts resizing. Thread 2 also sees capacity full, starts resizing. Now both threads copy the data into two different array, update count inconsistently. Okay, that's why thread is very that's why string builder is very dangerous in case of multi-threading. It's not a thread safe, not safe even for read during writes, can crash JVM. So how to fix this one? Without using synchronized, we can go for string buffer or we can go for a thread local. Each thread will get its own instance if we go for a thread local. Thread buffer is internally thread safe, no internal synchronized, no corruption. Okay, now moving on to the next question, runnable plus deadlock. So we have created one static final object log1 and then another static final object log2. Inside the main method I have a runnable task. Inside that I have synchronized log1, next synchronized log2. Basically this is a synchronized block. I need to get the lock of the object 1 to go inside the synchronized. Here I need to get the lock of the object log2 to go inside this one. Similarly in the runnable R2 it's vice versa. First I get to get the lock for the log2 object and log1 for the log1 object. It's vice versa. Now what will happen? I am created the new two threads and I have started it. Actually this is a deadlock scenario. Why it is deadlock? Because we have started, thread comes here. Okay, it acquired the lock. If the moment thread comes inside this one, it indicates it acquired the lock of the log1 object. No other new threads will be allowed to acquire the log1 until my current thread releases the log1. Okay, now consider thread 2 came here. It came here because it acquired the log2, but in my thread 1 to come here I need log2. Similarly in thread in task 2 I require log1 to come here, but log1 is already held by that my previous child thread. Here I require log2. Log2 is held by the another child thread. So one thread is waiting for another thread to release a lock. Thread 1 is waiting for log2. Log2 is right now held by the another thread. Thread B is waiting for thread A to release a log1. So it is like a deadlock. So R1 locked R1, R1 locked R2, R2 locked R1, R2 locked. So it's normal execution, no deadlock. Happens when thread finishes both locks before the other interfaces. Okay, normal execution, no deadlock. Case to deadlock, and then program hangs forever. It is a mutual exclusion. Locks are exclusive forever. So R1 holds lock 1, waiting for log2. R2 holds log2, waiting for log1. So circular wait like this. Okay, we have received. So how to fix this one? We need to maintain the same order. If we have included the log1, log2, the same order we have to maintain in the next task. Or there is another advanced concept like re-entrant lock. It is an interface of the thread class. Re-entrant lock is nothing but just 1 minute. Recording is not long. A re-entrant lock is nothing but it is implementation of a lock interface and direct child class of object. Okay, so re-entrant means a thread acquires the same lock multiple times without any issues. Internally, re-entrant lock increments thread personal count whenever we call lock and decrements the count value. Whenever thread calls unlock, lock will be released whenever count reaches the 0. Okay, so yeah, this is the question for the, we can go for a re-entrant lock. So lock, I have created the two lock 1, lock 2. I have included try lock. Let's consider let's consider I have required thread 1 acquires a lock 1. Okay, if lock is available, it will go to this if block. If lock is not available, it will go, if any else block is there, it will go to that else block. Inside this one, let's consider my current thread lock L2 is held by some other thread, means it will check whether I can acquire lock. If it's not possible to acquire the lock, it will automatically go to the else block if that is available. The advantage of re-entered lock over synchronized block is we no need to wait until lock gets released by other thread. That is the main advantage of re-entrant block. Okay, also we have some time based locking, like we can wait for some 1 minute, 2 minutes, 3 minutes. If lock is not received, then we can go, and if lock occurred, we can go for some other implementation. If deadlock occurs when multiple thread acquires locks in different order. The best production fix is encouraging global lock ordering or using child lock with timeout. Next, this we have seen in our previous section also. A static, I have initialized one static boolean flag as false. I have created one runnable task. Initially it's false. I am calling new thread or dot start. I have started the thread. Okay, now after that I am assigning the flag value as true. What will happen, whether this will keep on running or it will come out? The answer to this, that is, it will keep on running, because internally thread has some cache. Okay, question is, can this loop run forever? Yes, by JVM plus CPU concept. Each thread has its own cached copy of variable. The main thread updates flag equal to true, but the child thread may never see this change. If we change this as volatile, then what will happen? It will go and see in the main memory and get the data. Okay. Moving on to the next question, question number 7. Runnable plus multiple threads using the same task. Int value equal to 0, value plus plus, system.out.println of value. Here I have a three task. I'm calling the start method. Okay, so what will happen here? Basically the value will be inconsistent. For this we need to, because each thread has its own variable cache, it might have not updated the data. Okay, each thread, basically, you're creating only one thread, you're calling that for 3 times. The value is unpredictable. You will see 2 2 1 or 1 1 2, something like that. How to make this a predictable? Use atomic integer. Then you will see the possible output as 1 2 3 or 1 3 2, something like that. Okay, because why atomic integer works here, it uses increment and compare and swap, so value is correctly incremented. But system.out.println calls by different thread can interleave in any order. Threads are scheduled by JVM and may execute the print at different times. So atomic ensure correctness of value, not the order of printing. So if here I have included system.out.println, that is executed by different thread. Okay, so ordering is not guaranteed, but ensure the correctness of the value. How to make predictable order? Go for the synchronized block. So in this question we have seen the value will be, after this for loop completion we will see value as 3, but the order execution here it will be undetermined, because system.out.println will be executed by some other thread. Okay, how to make sure the order, correct order? We have to use synchronized a block, inside the synchronized block. Then this ensures only one thread prints at a time. Okay, but still the order of which thread goes first is not guaranteed. Okay, moving on to the next question, runnable versus callable. Runnable is like a its return type is void. It has run method. Okay, return the results, handle exception, timeout, support. These are the 3 scenarios we have. Okay, why runnable fails here? Because return type of runnable is void, so we can't return the result. Exception thrown in runnable submitted to executive submit or followed unless you get the future. Only works if submitted via executed submit and you use the returned future. So if you just do runnable r equal to, then we won't see this error at all. Okay, so you can't get a return value, you may never see the exception printed. So runnable alone here is not sufficient. So what you need to do, you need to go for callable. So if we go for callable, here you can see it, callable string task, I'm doing something, future.submit, then I'm waiting for 2 seconds to get the result and then output. So by this way we can get using the callable. Callable service executor dot callable service dot call. This is also another way. If you have runnable but need to be callable, how to convert runnable to callable? Here I have runnable task, I want to convert to callable, means there is executor dot callable. There you can pass this runnable task, and if you call service dot call, then run method, this particular thing will be invoked and you will get the output. Here you can see, right, boom, something, it's printed. Okay, the next question comes in. Question number 9, runnable plus blocking queue produce a consumer problem. This is very important problem for an interview room. So whenever the producer consumer problem they are asking, we need to go for the blocking queue. There we can initialize the thread size. Here I have initialized with 2. Okay, runnable producer I'm including in the queue with till 5, and then consumer, if it is true, tries to take new thread of, I'm creating a 2 threads. Here you can see producer consumer. So what actually it will do inside the blocking queue, just 1 minute,
Maintaining 1 minute
inside the blocking queue, Okay, here what will happen, the producer will try to push the data to the queue. The consumer will pull the data from the queue. Uh, that's why the queue here is a shared buffer. Um, Consider a case where producer tries to push the data to the queue but there is no capacity. Capacity in the queue is 2. Okay, here I have initialized the capacity as 2. Till 2 only I can include in the queue. That is my capacity. Okay, so that is my capacity here. Till 2 only I can include. So here you can see you are using array blocking queue, its capacity is 2. So till 2 only the queue will put into the queue. If the queue is full, the producer produces produces 0 to 4, but the queue can hold 2. If the consumer has not taken anything yet, after producing 2 items, the producer will pause at the third put until the consumer removes an item. So the producer will definitely block if the queue reaches its capacity. Why queue size matters? It will produce and consume based on the queue size. The queue acts as a buffer between producer and consumer. If the queue is large, the producer may produce many items without blocking. If the queue is small, the producer will block sooner. So queue size is 0 like synchronicity. The producer consumer may operate in log step produce, cannot put until consumer takes. Okay, in your code, queue size is 2. Producer produces 2 items before it has to wait for consumer. The system throughput depends on the queue size. What happens if the consumer is slow? The queue will fill up quickly because the producer produces faster than the consumer consumes. Once the queue is full, the producer blocks at queue dot put until space is available. If the consumer keeps being slow, the producer remains blocked, which efficiently throttles production automatically. So queue enforces back pressure. Producer cannot overrun the consumer. Okay, so this is a simple runnable plus producer consumer problem. If you are not going for the blocking queue, what will happen? Normal queue, what will happen? We need to use wait method, notify all and all. Okay, that will be unnecessarily increasing the code size. The next question, runnable plus interrupt handling, most frequently asked. So I have created this task inside true. If it is interrupted, I am calling interrupted and then breaking. I am creating a new thread and calling the start method. The moment I call the start method, it will register the thread in the JVM and include the thread scheduling, and it will execute the run method. This will be executed. After some time, I am calling t dot. It won't print this block until this one. After that I am waiting for 1000 milliseconds. The moment I call t dot interrupt, it will come out. Because when we call interrupt, there is inside the thread there is some flag called isInterrupted. That value will be included as true. Okay, so if there is here we have a method called isInterrupted. By seeing this, the output will be printed as interrupted break. Try catch is only required if we call the method. By seeing this, people will get a confusion like thread will be interrupted or not. Okay, why not using try catch? Next question comes in. Only if any exception is thrown, we can use for try catch. Here inside the thread, no method throws a checked exception. Is interrupted does not throw any exceptions. Okay, so try catch is not needed here. If you were using try sweep or wait, you will need try catch for interrupted exception. Okay, is interrupted is check if thread is interrupted. Interrupted checks if thread is interrupted, clears the interrupt flag after reading. Okay, if a thread is in a blocking state like sleep, wait, join, calling interrupt will throw interrupt exception immediately. The interrupt flag is cleared when exception is thrown. You need to catch interrupt exception and handle it. Okay, is interrupt to check without clearing the flag. Interrupted you want to check and reset. Interrupted basically it will interrupt only when thread is in the sleep, wait, join, and you are calling interrupt, then it will throw interrupted exception. So in this section we have understood how runnable works with the executor service, difference between runnable and callable, and volatile, atomic, integer, and atomic, integer, and how to implement the producer consumer problem, and difference between the is interrupted and interrupt. So we don't here waiting for a sleep, nothing here. This interrupt is called after the sleep, after this execution only, so that's why interrupt exception is not there. So yeah, that's all for this section. In the next section we can look into the synchronization, static synchronized versus non-static synchronized. Okay. Thanks for watching my video. Feel free to include in the comment section.
What video?